So now I want to get into the actual subject matter for the day, which we're first going to start out with: what is a mathematical model? And a mathematical model can broadly be defined as the formulation or equation sets that express essential features of a physical system in mathematical terms. Essentially, can we write down an equation that's going to predict or describe how a physical system is going to behave? While maybe you don't think about this, we've done this a lot using things in general chemistry, like writing down reaction equations, reaction rates. Those are mathematical models. And so we usually want to put mathematical models, express those as some sort of dependent variable, which is a function, so this F symbol, of independent variables, so maybe temperature, pressure, a set of parameters, maybe, for example, the gas constant, and forcing functions, which maybe say prevents, are additional functions that are going to prevent uncharacteristic or unphysical behavior. So sort of just to reiterate, our dependent variables are going to be characteristics that reflect behavior state of the system. Independent variables could be thought of space and time, so x, y, z, or t, and parameters and external influences. So simulations are slightly different than models. So the simulation is the act of running that model or seeing how that model, or the act of seeing how that model is going to, what the result of that model is. So similar, but slightly different concepts. We're going to be implementing our mathematical models in Matlab, which was developed at the University of New Mexico, written in Fortran and improved on in C. So Matlab, we're going to get very familiar with, so hopefully you're going to find it fun and exciting. There's a bunch of resources available for learning Matlab. You can find these online at mathworks.com. You can go to Google or anything else and say, how do I do whatever in Matlab? And there's tons of resources online to help you with Matlab. And we're going to start off nice and easy, and we'll build up. So by the end of this class, you should feel very comfortable with Matlab. Here I've presented a getting started guide in case you want to sort of follow through that prescription. But the activities that we're going to do in the next few days should hopefully provide you at least the basics of Matlab, so you don't that you need for this class. So the key ways to learn Matlab are going to be through the books and the examples that we're going to see in class and through the lectures. I highly encourage you to follow along as I write Matlab code, to write the same MATLAB code yourself. The act of actually going through and trying these different codes is going to be very helpful in understanding how MATLAB behaves. Don't be afraid of failure. You're gonna, even very experienced coders have to go back and do what's called debugging. So finding all the small little things that's wrong with their code. So don't think like that it's, don't treat this as a homework assignment where you get to turn it in once and you either get it right or wrong. So the key thing is going to be just playing around. So testing, debugging, fiddling around, and you'll get it. Okay. So now that we've talked a little bit about MATLAB and functions, I want to show you what MATLAB looks like. So give me a second and I'll reappear in MATLAB. So now we're in the MATLAB setting. So I've opened up MATLAB. In this case, it's MATLAB 2020. Depending on which version of MATLAB you have downloaded and installed, your windows might look a little bit different or appear in different places. You can manipulate that using some of these layout slides right here. Let me pull up my spotlight. So you can play around with that up in this area if you want to change the look. But you should see several different things along the top. We have these a home tab. You should see this piece of the window, which sort of shows where we are. So I'm located in my C drive in a folder called Lectures in my CHE 384 folder. This window, this current folders window that I have shown here on the left, is going to show all the files that reside within Lectures. This is just a good way to keep track of what files you have open, what programs you've already written, and then will allow you to maybe call on some of these pre-written functions and files if you want to use their functionality. I also have pulled up the Workspace tab. This Workspace tab is going to show me all of the variables that I've assigned and an overview of what their values are. One of the main windows that we're going to work with is this command window. So it's this space here. So this is essentially the way that I can interactively send variables to and from Matlab. So let's see how this is going to work. So within computing programs, think of it a little bit like algebra. I'm going to take some variable, say x, and I'm going to assign it some sort of value, say 5. Right? So in this program that in terms of Matlab, I'm essentially carving out a piece of space in computer memory, and I'm telling the computer that anytime I have x within my program or within this window, it should really interpret that x to be a 5. So if I hit enter, Matlab comes back and it says x equals 5. It's just telling us that that variable x is 5. It shows up in that workspace area on the left where we see x with the value 5. So now I can go into Matlab and request that it returns whatever piece of information is stored in x. So say, for example, I can type in x, hit enter, and it will pop back out x equals 5. Why is this important or interesting? Well, having x equals 5 isn't necessarily interesting all by itself. The more interesting things are how we can manipulate this material. Because now I can say, for example, y equals x plus 2. In this case, x is an assigned variable, right? Matlab is going to say, hey, there's a variable here. I should go and look in my memory, in my workspace, right? And look and see what x is equal to. In this case, x is equal to 5. So when I plug it in here, I expect that y should come out to be 7. If I hit enter on my computer screen, that's exactly what will pop out. It will say y equals 7. And all of a sudden, y shows up in my workspace and as a variable, and within that variable is stored the number 7. And I can do any sorts of operations that I want. I could say maybe, what's x divided by y? In this case, I don't have any variable that I'm assigning it to. I'm just essentially using this as a calculator. So when I hit enter, I should see 5, which is x divided by 7, which is y. And I get this number, ANS, for answer. So the answer of my question was 0.7143. So x and y's are my just typical variables that we're used to dealing with in algebra. But I can make any type of variable. I could say maybe x2, instead of equaling 5, maybe x2 equals 1.5. I don't know. When I hit enter, that's now going to store x2, and that's going to show up here. So I can use any combination of letters and numbers, usually wanting to start with a letter, as a variable. So now if I go, I can either say go back and type y2 divided by, sorry, x2 divided by y, and hit enter. And now I have, it's going to pull this 1.5 to divide by 7, and we end up with this 0.2143. I can do any of the mathematical operations that I'm normally used to doing. So I can say, 2 times 3, 6, using the asterisk. I can do 4 divided by 8, using the slash. I get a half as I expect, and then addition and subtraction, 2 plus 3, 5, 2 minus 3, -1. And I can do all of that with variables or with numbers. So we can just say y minus x. And this is a number, -2, because it's 5 minus 7, behaves just like we expect it to. We can do other types of mathematical operations. So say what's 3, we can do it with the variable. So what's x squared, right? So here I can take x, use the caret for an exponential. So move up over 2. So x is 5. If I square it, I should get 25 when I hit enter. This is what I get. Another useful one would be exp. So what's e to x, right? So that's 2.3 something to the 5th power in this case, comes back as 148. Here, I input these parentheses to show that I want to take the exponential of x. I could do, say, the same thing with square root, sqrt of x, and we get the square root of 5. And so within those parentheses are going to say, submit x to the square root function, and it will do that. Same thing, I can take, say, the natural log of x. Oops. I can take the log of x. We can do when I type in log, it's going to give me the natural log of x. And when I type in log 10, it will give me what we normally think of as log. So that's one little tricky thing about Matlab. So log is going to be natural log, and log 10 is going to be what we traditionally think is log. Right? So I can do these things with variables, and I can put more complex features in here. So maybe say square root of x plus y. Right? So it's first going to go in here, add x plus y, and then take the square root. So it's gone 5 plus 7 is 12, and taking the square root. If I type in sqrt of 12, I should end up with the exact same number. Right? And so just like before, I could assign these to variables. So I could say a equals square root of x plus y. So now that 3.4641 has been stored in A. What happens if I change x? So this was calculated with x was equal to 5. What happens when x equals 6? So when x equals 6, we can see over in the workspace, we've overwritten that old x equals 5, right? So here we can see that x is now 6. A hasn't changed. If I type in A, I still come back to 3.4641. This is because A was written, or A was stored in memory. The answer of square root x plus y was written when x equaled 5, but x doesn't equal 5 anymore. If I want to go back and change A appropriately, I need to either retype A equals square root x plus y, right? And so now I have the new answer. Or I can use the up arrow key to navigate to a previously entered value, a previously entered formula, and hit enter. Right? And so essentially this is a way we can sort of play in this sandbox and build many different, lots of variables and try out different mathematical functions. Storing all those variables here. But this can be cumbersome, especially if I want to do things over and over again, or if I have a very complicated program. Just finding out what 2 plus 3 isn't very useful. Where this use is going to come in is when I want to build up a series of commands for for MATLAB to do for us, and do them over and over again. So what we want to do is we want to build a script or a function. So I'm going to build a new script. So going to new script, and that's going to pop up in what's called an editor. So a script is essentially a series of commands that are going to be done in that exact order. So we can say maybe x equals 5, y equals, what do we have, 7. Then a equals the square root of x plus y. So in order to run this, I have to save my very basic computer program. So let's save it. So we can go over to the Save button, click Save As, and we can save it as maybe my first program. When I hit Enter, we should see my first program pop up over in this window. So once it's saved, I can click the Run button. So when I hit Run, we see all the commands that I typed in show up in the command window. We first see that it does this double arrow for input. It says my first program. Then it shows x equals 5. Oh, that's the exact first thing that I put in. Y equals 7, once again, the first thing that I put in, and a equals 3.46. Right, that's the evaluation for my square root. What we'll also notice is the variables in the workspace have been modified appropriately. So essentially, if I want to write down a whole list of things that I would normally put into the command window, I can put them into a script and it'll run exactly that. Sometimes we don't want to put in we don't want all this information to pop out to the screen. In this case, I've only have 3 commands that are taking place. But as we get to more and more complicated programming, it may be hundreds of variables being written to the screen, which can get very confusing. So MATLAB will let you put in this semicolon. The semicolon means don't print the result to the screen. You'll also have noticed that MATLAB has highlighted the equal sign. This is just done as a way to help you to say, this is going to get printed to the screen. It also, over in this right-hand side, highlights this in orange. Printing things to the screen is relatively slow. Once again, this doesn't matter with such a small program, but when you get to relatively large programs, the actual displaying of these numbers can take a serious amount of time and really slow down your system. So oftentimes we want to hide these. So this time I'm going to change this up a little bit. I'm going to set x equal to 25, just so we get a different number. I can click Save, and then when I'm ready to run, I can either click the Run My Program, or I can type my first program into MATLAB and hit Enter. This time, the code ran. You can tell because over in the workspace, x is now equal to 25, and a is equal to 5.66. So it's changed those variables. However, nothing's been printed to the screen. This is because I've put in these semicolons. So scripts are going to be very useful. They're going to allow us to move information in, do something over and over again. But sometimes we may say, well, I don't always care that x is 25. So instead of continually going in and changing x equals 25 and running the script, we can run a program. We can write a function. So here I've just opened a new tab in my editor. And right now it says untitled 2. So we're going to write a function, and the function is going to take in a variable or more, and it's going to return some sort of variable. And we tell Matlab that it's a function by writing function. So we type in function, and then we're going to tell Matlab what it should return. So what do I want out of it? Well, if we're interested in the square root of x plus y, we should probably, if we were interested in that a, which was the square root of x plus y, we can write in a, and it's going to return a. And so maybe we can call this, so then we set equal to, so what is a equal to? This is going to be now a name. We had previously called it my first program, but maybe we can call this my first function. Okay, and so when we typed in my first function, we then typed in 2 parentheses to say this is what it's going to take in. You should have seen that when we did that, the highlight on the equal sign went away. That's because it's now recognizing that this is a function. We now need to tell Matlab that it needs to take in x and y. Right? So here we have x and y, and we'll see that x and y are now highlighted, and a is also highlighted with this red underline. These are being highlighted because nothing's done with x or y, and a is also not used, right? So Matlab just trying to be helpful here. This is okay. We're going to write the little bit of code in a second. The next thing that we want to do is we want to type end. It's essentially a way for Matlab to know, okay, I can stop, right? This is giving Matlab essentially its reward. You've completed everything I told you to do. It's time to stop. But now we're ready to write what the function is supposed to do. Now remember, we had said in our script over here, we typed in x equals 25, y equals 7, and then said a equals the square root of x plus y. Here, we don't have to tell Matlab what x or y is because that's going to be input into this function. So all we need to do is say what a is. So a equals the square root of x plus y. And now here I have a decision to make. I can either put in the semicolon such that it won't print out this line to the screen as the function runs, or I can remove that semicolon and it'll print that line out. I'm just going to let that ride for a second. So now when I go to save this, it's going to pop up and it's going to try to save this. It's going to save it as the name, my first function, because that's what the name of the function is. So we can hit save. My first function shows up in that screen and it's ready to run. So how we can run this is we can say my first function, and we can give it different values. So maybe this time 30, comma, 4. When I hit enter, it prints out a, because there was no semicolon here, and it says the answer of that function was 5.831. What you'll notice is this a value in the workspace stayed at 5.66. This is because what happens within the function call does not affect the numbers that are happening outside. Think of it this way. We've written down a bunch of numbers on one piece of paper and a bunch of instructions on a separate piece of paper. We've gone and we've given those instructions and the input numbers to somebody in a different room. After they've done calculating that, they bring us back the answer on a new piece of paper. Right? All the scratch work that they did is left away. The only thing that comes back is the answer. This is going to be really important as we're going through functions to remember that within each function, we can rename any variable that we want, and that variable doesn't get passed back and forth.